Okay, so now we're going to look at if I'm given some information about a line, get the algebraic representation. So now that information, it might come in the form of a table, but we'll look at that later. So here you're just maybe told. So the simplest thing is, you know, I would like to come up with a general straight line. I'd like to come up with its slope and its y-intercept. So remember, m is the slope and b is the y-intercept. Okay, so I want to come up with those two things. Well, sometimes I'm just told, you know, so you know, I might be told something like the line has a slope of -4 and an intercept. Now really we should say y-intercept, because you could talk about an x-intercept where it crosses the x-axis, but and a y-intercept of 6. Well, in that case then I know just from that that since m here is the slope and b is the y-intercept, well then I know the equation for this line, or the algebraic representation of this line, is simply -4x plus 6. So, you know, I wish things were always that easy. They're not necessarily always that easy. Now, in that way, I could be given that same information, that same kind of information, but I could be told in a more real-world way. I could be told that we start with something like, you know, and 6 tons of stone, and we can remove the stone. Okay, so I can remove this stone and spread it, I guess. At a rate of 4 tons per hour. Okay, so I'll hit my thumb on the little mover thing there, and so you know, you might be told this way. Well, how is that situation? Well, if we think of this in terms of coordinate pairs or data or something like that, you know, I would have something like, well, I could talk about hours, and you know, and tons of stone. So I'll just say tons. And at 0 hours, because it said we start with, oh, I've got 0 and 6, and then 1 hour later, well, I've spread 4 of it, so I guess I have 2. But if we think about that, what we see is, if this is X and this is Y, now this is hours, so actually I'd probably use a T or something, and this is tons, so actually I'd probably still want to use a T there. Well, I can't do that, but it's tons of stone, so I might use an S, or I might still use a T. But this says, okay, we start here at 0, 6, and then we go down to 1, 2. We're talking about a line that goes like that if we assume this is a line. And well, I'm going to assume it's a straight line in that, it tells me the important part of the straight line is the idea of the slope, and it says I can spread it at a rate of 4 tons per hour. That's a constant rate of change, and that's what a straight line is. And so since we're taking away 4 tons per hour, and see the slope here, it tells me, it helps me with the slope, because if you think back to module 1, then we were told Y is in tons, and so as I look at this, I see that it's a rate, and so I think, well, that's probably a slope, but that also works out really well in that if I say M is tons per hour, like that, that would make sense, and my X would be hours. And you see, if I take my hours times my tons per hour, the hours cancel out, and I just get the tons. And so this is making me think, okay, this is my straight line then. I can tell you the number of tons of stone, and then equals, and my slope. Now I'm taking it away. Okay, that's very important. I'm taking it away, so that's negative 4x. And then I started with the 0, 6, so that was my y-intercept. So you see, I've been given that same information. I've been told the slope is negative 4 and the y-intercept is 6, but I've been given that information in the context of something slightly more real. And certainly, I'm going to say this is real in that I have a stone driveway. I have ordered stone before and gotten, well, I've done it a couple different ways, but one time I had to have it just dumped in a big pile, and so then I needed to spread it. And, I had this big pile of, and it probably was around 5 or 6 tons. Now, I don't think I was spreading it at quite 4 tons per hour, but I was spreading it, faster than, say, 1 ton per hour. Maybe I could spread it as fast as 2 tons per hour, loading it into a wheelbarrow and so forth. But that really is a real situation. Now, did I need to describe it algebraically at that point? No, I did not. But there are other processes that we do need to describe that way. But notice, it is that same information. I was just told, here's your slope, and here's your y-intercept, but of course it didn't say it that way. And I had to understand from the reading about the, when I remove the stone from my pile and I spread it, so I remove it and spread it, I'm actually talking about a negative slope, because if I think of y, now I didn't say that, but I actually should say that here. So where y is tons of stone left, okay, because I'm removing it from the pile, so it's the tons of stone left, and X is hours. Well, I guess of removing. Okay, so there's one way to fill in that algebraic information is I simply am told the slope and the y-intercept. You know, they say M is and B is, and I just fill them in. But the key in the real world and how you can actually use this is, well, they aren't going to tell it to you that way. You know, you don't tend to say to people, oh, by the way, you know, could you please, you know, give me a y-intercept of stone of 6 tons? You know, you don't say that. You just say, give me 6 tons of stone. And then, you know, somebody else might say, well, yeah, you know, you can, or I can, or whatever. Spread it. You know, we think we can probably take care of this at, you know, maybe 4 tons per hour. And great, you know, so that tells you, but they didn't say, oh, and by the way, we'll be able to remove it from that pile and spread it with a slope of -4. You know, that's just not what we say, and that's okay. We also, if we're English language speakers, we don't say it in Spanish and we don't say it in French. You know, algebra and graphs and so forth are different languages, but they're the languages of math. And so what we need to do is learn those languages and how to translate. And so we have to look for what do things mean in the English and what do they mean in the mathematics. And then we can match them up. Okay, and you know, so I was able to match up this y-intercept and this slope by thinking about what those things meant in English. Okay, and we'll do a little more with the slope-intercept form, but we'll call that video good for now.